Hey, my calculus people. Here's a little help on the worksheet from 4.5 and 7.8, which talks about end behavior graph and L'Hopital's rule. So it goes with those notes. If you haven't watched those notes videos, go back and watch them. They're pretty sweet. I'm actually going to do this in reverse. So I'm going to start helping you on the back page first. And that's because I think sometimes L'Hopital's rule isn't quite necessary, especially with the limits at infinity, but I do want you to know it is possible. So, I don't know, we can pick any one of these. And what's cool is it doesn't matter if you pick one that goes to infinity or one that goes to 2. If your answer after plugging in results in infinity over infinity or 0 over 0, then you can use L'Hopital's rule to take the derivative of the top and the derivative of the bottom and then try the limit again. And you may end up doing it multiple times. So for instance, let's try, I don't know, let's try this one here, number 2. Okay, so if I plug an infinity in here, you got infinity squared times 3, so the top is infinity. The minus 4 doesn't matter, right? The bottom, I put an infinity in here, and you get negative infinity, which still is undetermined. I don't know. What's weird is sometimes infinities approach faster than others. It's more like a speed rather than a size. So I'm not ready to commit to an answer on this because right now it looks like -1, but this is indeterminate. So this is a time when you can use L'Hopital's rule. And L'Hopital's rule says go ahead and take the derivative of the top and the derivative of the bottom and then try to plug in infinity again. Okay, so the derivative of the top is 6x, right? The derivative of the bottom is negative 16x, because the 4 goes away, the 7 goes away. And then I try it again, and I get infinity over negative infinity again, which still isn't good enough. So you just do it again. That's what's cool about L'Hopital's rule. If you want to, if you ever get infinity over infinity or 0 over 0, you can just take the derivative of the top and the derivative of the bottom, and then plug in your number. Now here, see how there's no more number to plug in, so I'm left with negative 3/8. Okay, you could have done this the other way too. One thing to remember is if you get an answer of infinity over something, right, the answer is infinity. But be careful that you check whether it's positive or negative, because it depends which way it goes. And sometimes they'll put a little negative sign in here and have you plugging in a negative infinity. If you ever had the reverse of that, like 5 over infinity, that's worth 0 because you're dividing by a ridiculously big number. Okay? So that's help on the back page. You can do the other ones. Now, we're still going in reverse because then we come here to these problems, and here is the tricks from 4.5. So before you learn L'Hopital's rule, sometimes the 4.5 trick is even more helpful. And that's where you just take the first term in front, and that's what counts, because as you go to infinity, the numbers at the back don't matter. Like you can just get rid of that 2, and you can just get rid of that -1, and then you can simplify it as you go. So I don't know which one to pick. Maybe, I don't know, maybe this one here. Let's go to this one. Okay, so as I get bigger and bigger, or actually you're going to negative infinity, see that? It's pretty small, but as I go to negative infinity, that doesn't matter at all. And the graph behaves more like this over this, which simplifies to be this over this. Now, if I plugged in a negative infinity for x, I'll have 5 times negative infinity over 1, which is negative infinity. Goes on forever. Down, actually. That would tell me, that's what's kind of crazy. This means as I go way left on my graph, the y values go way down. So my graph, I already know without ever looking at a picture, this graph dives down to the left. And if I would have put a positive infinity there, it'd go way up. And I guarantee if we graph this picture, right, 5x, oh shoot, I'll do the little fraction button because you guys love that thing. 5x squared over x plus 3, and we graph it. It's going to graph eventually, I think. Here we go. Shoot, I gotta zoom out a little here. Oh, crap. No. Yeah, that's right. Let's see if I type that in right. Zoom out. This is just still going. Alright, hold on. Alright, I'm not crazy, and I'm not a liar, I swear. This graph, I couldn't tell like where it went down, so I had to go to the table. This is why when we put it together with all our other max and mins and asymptotes and stuff, we'll be able to. It starts going negative at negative 80 and stuff like that, so I need to zoom way out. Maybe I can zoom fit. I wonder if that'll show it. Sometimes zoom fit is good. There it is. So it's going to eventually dive down out there on the other side too. So it's going to go to negative infinity as you go farther and farther left. Maybe I zoom out again. You'll start to see the graph will dive way to the left. Yep, it's starting to curve down. Just got to zoom out a few times. Anyway, or look at the table, because the table will show you it diving downward eventually. Anyway, that's the kind of stuff with these. You can do those. What's different on this that I didn't do in the notes? Alright, so now to the top ones. And these will go, here's what's weird about these. Every one of these matches with the picture. So worst case scenario, if you know, I want you to do these without using your graphing calculator, but you can use your graphing calculator. There's one or two that are a little questionable because like this one, there's one, where is it? Here. A and H are probably the hardest two. No, those aren't. We'll see. We'll see. You'll run into it. Oh yeah, it's this one. E and B. See how they both approach 0 from the left and the right, and this one approaches 0 to the left and the right? The difference is one of these approaches 0 from the bottom and the top. This one approaches 0 both from the top. Really hard to see. I'll try to show you that one as an option. Okay, but let's pick number 2 here. Okay, number 2 is a good one to look at. So if I were looking at number 2, on each one of these, I want you to think about the limit as x goes to positive infinity and the limit as x goes to negative infinity. Okay, and here remember the plus 2 doesn't do anything, so it starts behaving like 2x over square root of x squared, which is also known as x. Once you get that 2 out of the way, you can actually take the square root of the x squared. We did one of those in notes. So it behaves like 2. And this one you can do the same thing. However, remember in notes how I said you got to be careful with the sign, because if I put a positive huge number in top, that makes the top really positive. If I put a positive huge number in bottom, it makes the top and square it, and then it makes it big, and then square root it, it's still positive. This answer is cool. So as you go right, your graph approaches 2. As you go left, think of putting a negative huge number. Now if you do it here, you won't be able to notice because it'll look like a negative over negative. But if you put a negative huge number here, it makes the top negative and it makes the bottom positive because you're squaring a negative and then square rooting it. So you have a negative over positive, which makes your answer negative 2 left. So I'm looking for a graph in this picture. As I go to the right, it approaches a y value of 2. As I go to the left, it approaches a y value of negative 2. Okay. There's only one of these. See this one? As I go right, it approaches a y value of 2. As I go left, a negative 2. So C is my answer for 2. Oops. Okay. So these are pretty cool because you got to do both of them right. Then you got to find the picture, and I like that it's connected to the picture because that's why we're learning these. We're learning these so you can tell what the heck your graph does at the end. Remember, it doesn't matter if it wiggles or jumps or scoots or does anything weird in the middle. It's what does your graph do at the end. Let me see if we can do one of these zero ones. Okay, so okay, let's go with this one here. How did I know it was a zero one? Because it's a bottom heavy one. The limit as x goes to regular infinity, that's from way out to the right. And remember, the plus 1 doesn't do anything. And then the limit as x goes to negative infinity. Now, the answers to both of these are 0, right? Similar to this last one. However, I got a question. Even though there's no such thing as positive 0 and negative 0, you can actually tell if the number before the number got to 0, was it a really, 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 really tiny positive number, or was it a really, really, really tiny negative number? And you can look at the equation to see that. Think about putting a huge positive number in here and squaring it. It makes it positive, right? So you have a positive on top, and you have a huge positive on bottom, which makes your 0 positive. It's a tiny number, but it's a tiny positive number before it goes to 0. Same with if you put a negative infinity in here. If I put a negative infinity there and I square it, it makes a huge positive number on bottom. And it already has a positive number on top. And when you have a positive over positive, it makes it positive. So I want to see the graph that approaches 0 from above, slightly above as you go right, and slightly above as you go left. Okay, so that's this graph. See how it's approaching from above, from above. So B is my answer for 7. Okay, so try that out. I think these are really cool, and they give you a lot of practice with like having your brain think, does it approach positive infinity, negative infinity, and you get the whole, here's a bottom heavy, so it's got to go to 0. If it was top heavy, it would go to infinity, that sort of thing. If they're even strength, it goes to an actual number. All right, anyway, hope that helps, and yeah, I will talk to you guys later. Try these out. I am going to ask you next week to submit these worksheets from this week with a picture. Okay, I'll probably make a Google form, maybe. Yeah, I'll do a Google form where you just upload your picture of it. Okay, so be on the lookout for something to pop up on Classroom where I ask you to submit this. All right, people. I hope you're doing well. Email me. I miss you guys. You're an awesome class, and I will. I'm going to be having surgery here on my ankle and leg, so I will probably not be back until the new year, and so it'll be until then. But I will still be around. You can always send me messages and ask me questions. All right, folks. Talk to you later.